Okay, well, how's everybody doing today?
Pretty good.
Pretty good. All right, good to hear it. Well, we will get on to our focus activity in just a second. A few items. Tomorrow, what is happening? Okay, you're going to have your quiz, but it's going to cover what? Okay, so normal distribution. Okay, if we want to go ahead and maybe review at the end today, just let me know. We can go ahead and take care of that. But we have the quiz tomorrow. What's coming up Monday? Okay, the exam. Okay, so the exam is going to cover standard deviation. It's going to have normal distribution on there, and it's also going to have correlation. And I'm just thinking, when I gave you the notes yesterday for correlation, did I give you the assignment?
No.
Okay, so remind me, and I'll go ahead and get that to you today. All right. Let's say Friday. Okay, let's say Friday. All right. Now, I don't think we should have anything interfering with our class because the pep rally is tomorrow, but people aren't out of class until 7th, right?
No, 8.
So it's only 8th period. So nobody leaves early for 7th?
I still think it at 8.
Okay, so you will be leaving early. Do you know how early? Okay. Okay, so that's pretty much the entire period, so we're still good. Okay, good. All right, and then other than that, next Friday, not this Friday, is the end of the 6 weeks, so we're going to have quite a few grades left. The focus activities themselves are going to be due next Wednesday. You'll receive your 6th and last one for the set on Tuesday, the day after the test. My goal is to start linear regression this week. We'll finish it next week and go ahead and talk about a really important strategy for a lot of you in your IAs called the chi-squared test for independence, but that's kind of what is going to be happening the rest of this week and next week. Are there any questions? All right, well, let's get to it. So this one goes back to box and whisker plots, see what we remember. Now, speaking of like a review, remember on your test, I also did put what kind of problem? A cumulative frequency. Okay, so we want to be looking at that as well. So a set of data has a lower quartile of 31.5. Okay, so that would be Q1. A median of 37 and an upper quartile of 43.5. All right. And what we're going to need here says A, calculate the interquartile range for this set of data. So what exactly am I subtracting? Yeah, there you go. Remember, the IQR is just going to be Q3 minus Q1, which would be 12, right? Or did I make a mistake? No. 43.5 minus 31.5? Okay. Now, what's the range then? The maximum minus the minimum. Okay, that's the span of all the elements in my set. Okay, so it says B, calculate the boundaries that identify outliers. Okay, so does anybody remember those two little expressions I used for that, Spencer? Okay, so he's absolutely right. We have the IQR was equal to 12. This is B. So we have, trying to remember what he said, 31.5. So Q1 minus 1.5 times the IQR that we just found. Okay. And then what's the upper one? Okay, so Q3, 43.5 plus 1.5 times 12. Okay. And I previously worked those out. What are you guys getting? For the lower boundary, what did you get? I got 13.5. So 13.5, and then, yes, I got 61.5 for the other one as well. Okay, so those are my boundaries. Now, anything beyond that is going to be considered an outlier. Now, it does say the smallest values of the data set are 13 and 20. The largest values are 52 and 55. Which of these would be outliers? Only the 13. See, the 13 is below this minimum boundary. Okay, 20 is not. But 52 and 55, they don't go above the upper boundary. So 13 would be the only one that's going to be considered an outlier. Or outlier, depending on how you want to say that. Yes?
So it has to be either below?
Yes, so this is your lower, and this is your upper boundary. So any value in your data set that's going to be below, in this case, 13.5, or anything above 61.5 will be considered an outlier. Okay, since all the other ones are within those two boundaries, they're perfectly good. All right, and then it says for D, draw a box plot of the data set. Okay, so let me see here. I can get a nice little arrow going. Make it look somewhat nice. So let's see here. We got to go all the way from 13 to 55. So let's say 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55. Okay. So just enough room. And I just went ahead and marked a couple of them so I know which one's which. All right, so what was my median again? 37. So 37, I'd say is probably right about here. Okay. And then my upper quartile was 43.5. Okay, so maybe right about here. Okay. And then my lower quartile, 31.5, so really close here. So there's my box and my whiskers. We know that the minimum value is 13, so maybe right about here. And then we're going to end up, 55 was the largest. There we go. And there's my box and whisker plot. Any questions? Anybody have that completely done before I came in? Okay, Spencer? Okay, good. Nice. All right, so go ahead and put that someplace safe. You got 2 of them now, 4 and 5. You'll get 6 on Tuesday. Remember, they're going to be due on Wednesday. All right. So let's see what we started talking about yesterday. I got a lot of these open. Let me go ahead and close some of these down. Yeah, let's see. Okay, so we're on correlation. Okay, so we started talking about correlation yesterday, and graphically, we're looking at these scatter plots, and the strength or weakness depends on how close or how far away those points are with respect to each other. The more tightly packed, the more clustered they are, the stronger the correlation. The further apart they are, the weaker. And that's what this Pearson's correlation coefficient is. R, it's a numerical value that describes to you how close or how far apart they are. So do they have a pretty strong relationship or do they not? And then it could be positive or negative, depending on how it falls, up to the right or not. And then we did one by hand. And I believe we got a way, I showed you how to do it in the calculator, right? So it was very similar to what we had done before, but after we'd gone to stat calculations, what were we choosing? Not one variable, we're choosing 2 variables because we're actually comparing 2 quantities here. And we'll probably get the opportunity to go ahead and do that again today. All right, well, let's just go ahead and take a look at some information here, what we have. So a scatter diagram, it's a method by which we can obtain a quick visual appreciation of how 2 variables are related. Usually the independent variable runs along the horizontal or x-axis, while the dependent variable runs along the vertical or the y-axis. All right, so is anybody already thinking with respect to their IA that they could possibly be comparing 2 different quantities? Okay, so this is definitely something maybe you want to think of, not only showing it visually as a scatter plot, but remember, I believe I mentioned this yesterday, if you want to go ahead and incorporate the correlation coefficient, you want to walk the reader through. I mean, you will need to go ahead and show like a table and show how your values are giving you the coefficient that we got. So let's see. We talked about direction, increasing or decreasing, meaning positive or negative slope. And then we got a couple of screenshots here. We have a positive correlation, sometimes no correlation because they're just so far apart, or a negative correlation. Now, the form depends on the general shape of the scatter plot. Now, really, you could use any type of model to go ahead and help us with what we're comparing. We got parabolic, cubic, exponential, but in here for IB, we're only going to be interested in linear. Okay, so that makes it a little easier. Okay, the strength of the relationship. Now we have some values here. So a little more specificity on exactly what the value is going to mean. We're going to say there's a strong linear relationship, okay, if the value ranges between 0.75 and 1. Okay, but now 0.75, of course, is not included. And remember, does anybody remember yesterday what I said 1 was? It was 2 words, started with a P. Perfect. Okay. Oh, who said it? Carolina? Perfect correlation. Okay. All right. Nice. Perfect correlation. So if your value, whether positive or negative, falls between 0.75 and 1, we say that's a very strong relationship. Moderate, between 1/2 and 0.75. Weak, 0.25 and 0.5, and then no relationship at all if it's 0.25 or under. And in fact, this goes both ways on the scale. So if I were to look at it, okay, on a number line here, we can have 0 in the middle. Okay, so we have 1, we have -1. Okay. So of course we have our positive and our negative. So in either case, the closer we are to 0, okay, the weaker the relationship is going to be, whether positive or negative. All right. So the closer it is to 1, the stronger. And if it does hit 1, like she was saying, a perfect correlation, a perfect association. Okay. So outliers. In bivariate or two-set data collection, it's important to make note of any outliers that may occur. These generally appear as isolated points away from the main body of the data. Okay, now very important, outliers should be investigated when analyzing the data. Sometimes they can be errors in recording data or plotting it, but genuine, extraordinary data should be included in the analysis. Yes, ma'am.
So back to what you were saying about the strong versus like the weak relationships. What I thought you were telling me was like on the graphs, the closer it is to each other, the stronger the relationship.
Yes. So numerically, you would have something closer to 1.
Oh, okay.
So like if I were to just to go ahead and say, okay, so she's asking about the value itself, like how close or how far apart the points are going to be. So if I were to have, or in fact, let's go ahead and just, instead of my making one, let's just use this guy right here with the positive correlation. If I were to go ahead and draw what we call a regression line, or we also call it a trend line, or more often than not, you've probably heard it referred to as a best fit line. Okay, because it doesn't hit every single point. We try to fit the data as best we can. It's not going to be perfect. So looking at this one right here, it's definitely a positive correlation because it's going up to the right. But would you say that represents a stronger or a weaker? I'd say stronger because all those points are much closer to each other and to the line itself. You have roughly the same amount of points above as you do below. So I might go ahead and say that this, got a text message, I would definitely say that this goes ahead and falls in the range between 0.75 and 1. So if I were to go ahead and say, you know, your correlation coefficient, that value came out to maybe a 0.89. Well, then we would be visualizing in our head, okay, we've got a bunch of data points, but they're very close to each other. They're almost probably very linear, okay? Or if I were to go ahead and say, okay, you've got a correlation coefficient of maybe a 0.12. What are you kind of picturing in your head? Yeah, extremely weak. I'm thinking a bunch of points that are so far apart. I mean, I probably could come up with an equation line, but it's probably not going to be very legitimate. Anything I go ahead and predict based on it is not going to hold water, I should say. Does that kind of help? Make sense? Okay. Good, good, good. So that's what that number represents. Whether positive or negative, the closer it is to 1 or -1, the stronger the relationship. So this one right here, with it being that far apart, I might go ahead and say we're maybe 0.2, somewhere in that neighborhood. Okay. All right. Good, good, good. Now this is the big one. Okay. Because, you know, in your IAs, you're going to be attempting to persuade the reader to your point or trying to convince him or her of something. So causation, correlation between two variables, does not necessarily mean that one variable causes the other. Okay, consider the following. The shoe size and reading levels of children from elementary through high school were studied, and a strong positive correlation existed between the two variables. Does this mean that large feet make someone a better reader? No. It's just a coincidence. I mean, it happens to be the data that was collected. I mean, imagine you're sitting in a classroom, and on days when you take maybe a quiz or a test, it's raining, and you go ahead and do better when it's raining. Okay? Does that mean every time it's raining, you're going to do better? No, I mean, data could show that there's a positive, strong correlation, but that doesn't mean causation. Okay? So you have to be careful with this, even though the data might indicate one thing, you just want to really think about what is the relationship that's happening here. Does that make sense? Okay. And then it says when variables are related so that if one is changed, the other changes, we can say there's a causal relationship existing between them. All right, now before we go ahead and move on, let's go ahead and see if we can remember those formulas from yesterday. There were three different formulas that worked together to give me that variable R. Let's start with the S sub xy. Do you remember what we called that, Eli?
I can look. It was a
Started with a C.
yeah, it was a correlation.
Oh, not correlation. Spencer, you want to help me out? The covariance, yes. Okay. All right. So S sub xy, what was the formula? Does anybody remember? Okay, Eli?
X minus X
Okay.
minus Y minus
Okay. There's just one thing we're missing. Okay, that's sigma. Now for the covariance, we don't have a radical. Okay. So remember that capital letter sigma in mathematics, that means summation. Because one of the things we did yesterday when we created the table by hand, we had that one column where we took the product of these differences here, and then right at the bottom we took the sum. So this right here represents our summation. Okay, and then we had S sub x and S sub y. All right. Okay. And now these, specifically for the x's and the y's, what were these representing? Something that we've previously been studying and is going to be on the test. The formula for S sub x told me what about the x values? Okay, it gave me their standard deviation. That's what S sub x is. S sub y gave me the standard deviation for the y variables, the other set. Okay. Does anybody remember what that formula was? Okay, Libby?
So it was the square.
Okay, so I've got a big radical.
And then on the top would be the sigma.
Okay, so sigma.
And then parentheses. X minus the square root of x. Or not the square, the mean of x.
Okay, so x minus the mean.
And then the end parentheses. And then on the bottom square.
And are we missing anything? Squared. There we go. That's the only thing. Okay, the sum of the squared differences divided by the number of terms that we have. Now the same thing is going to apply for the y's, it's just we're going to replace the x's with the y's. So again, I've got this big radical here. So the summation of y minus its mean squared divided by n. Okay. Now, I think this is as good a point as any because it's really the first time we've gotten some formulas that you could potentially use in your internal assessment. The one thing that IB really doesn't like is if you use calculator notation. So you're going to want to make sure that you're using some kind of program that will actually write out a mathematical expression the way we would like it to be seen. Anybody know what I'm referring to when I say calculator notation? Like on your older calculators, maybe not so much on the Inspires, but let's say if you wanted to go ahead and take a variable and you wanted to raise it to a power, you know how you'd have to use that caret button, like the top of a house. So sometimes when you see it written, you might have, like that. Okay. That's what we're referring to when we say calculator notation. Okay. In fact, as part of the criteria, one of the 7 criteria that I have to go ahead and grade it by, they want me to take off points if calculator notation is used. And this is just something that I'll just keep mentioning, as we go through. But really, you could probably find yourself a nice bit of software online that'll take care of this. I know nowadays, Microsoft Word, don't you have to pay for that?
Yeah.
I know Word has an option where you can click on it. I think it is the pi symbol, and it gives you all these different formats and templates for mathematical expressions. Yes, ma'am.
So that's a caret squared.
Yeah, so that would represent what we would know as a squared. Yes.
So like when we're writing our AA, like how would we avoid using how would you type in an X?
Well, like what I always do, because I have Word available on here, so I can just show you very quickly. I'm wondering if we could just do an internet search. I'd hate to have someone, pay for it because I don't understand why you have to keep paying for that now. Do they? Now, is that true? I've heard that we're going to, now I don't know if this is true, but I've heard that we're going to just be replacing all the computers in the building with Chrome. Really? I really hope we don't do that. That is not going to be a good idea.
School has that. They got rid of all their laptops.
Really? I hope they don't do that. Okay, so like for me, when I'm typing up, whether it be notes or the assignments or something, normally that I give you guys, I use the Word program right here, and you'll notice you could insert, okay, and over here we have equation. Now I went ahead, see, and you got anything here you could possibly want. All your mathematical symbols. I mean, I could put in any type of fraction, superscript, subscript, radicals. I mean, it's trig functions, everything. Now, I went ahead and pinned it so that it's at the very top of any document I open up. So you may need to do that, but you can always just insert it. Okay. I'm sure there is. I'm not as familiar with that as this because I've been using this for years. I guess if everything's going to Chromebooks, I probably should become a little more familiar with that. Okay, so any questions on the formulas? Okay. Now remember, really when it comes to the paper exams also, I might as well go ahead and throw this out there. A lot of what you're going to need, you're going to be provided a formula booklet. Okay, and I think I went ahead and uploaded a copy of last year's to the website. I would have to check on that. But for all the different concepts that we're going to look at, they give you a lot of these formulas and things like standard deviation that you would need. So you don't necessarily have to memorize these. And remember, anyway, what are you allowed to use on both your paper exams? The calculator. So it's really more important that you know the keystrokes. If you know those, you should be good to go. Okay. So let's see, here are the three formulas that we were just talking about. Yeah, and when I go ahead and put them together, that correlation coefficient R, if I take the covariance, S sub xy, and divide it by a product of each set's standard deviation, that's going to give me that numerical value that Libby and I were talking about a little while ago. Okay, the closer it is to 1 or -1, the stronger the correlation. The lower it is, the closer it is to 0, whether positive or negative, that means the points are further apart, that's the weaker. Okay, so I've got another example right here. All right, table that's already been filled in for you. So I've got X and Y, and we found the mean. In fact, where's my paper? I'll just go ahead. Of course, it's right in front of my face. If it had been a snake, it'd have bit me. That was a joke. You'll laugh later. Anyways. Okay, so, we've already talked about this enough, so I'm just going to go ahead and give you guys the mean, and you can go ahead, and double check it for yourself on your calculator if you would like. But for the X's, I got the mean to be 3.875, and I got the mean for the Y's to be 3.25. Now, I'm not going to worry about filling out the table right now. I really just kind of want to do a couple things, kind of show you again how we would do it by hand, kind of walk a person through this, and then we'll go ahead and do it on the calculator again to make you familiar with the keystrokes. So you'll notice if I go ahead and take these data values here, like 1 minus the 3.875, that's where we got this first value of negative 2.875. Okay, each y value subtracting 3.25, 2 minus that, negative 1.25. Then we took a product of those differences. Negative 2.875 times negative 1.25 gave me that. And then we took squares of those differences. Now, what I need your help with in order to finish this off, which rows do we need totals for? The bottom three, that's exactly right. So somebody help me out. I need the total of this row with the product of those differences from 3.5938 all the way through 0.09375. I need the summation, yes. So we need all, how many do we have here? 1, 2, 3, 4, 5, 6, 8. All 8 of those values added up. Okay, and I went through this very quickly, so hopefully I have what matches what you give me. Hey, Spencer, what you got? I did not get that. I got 13.25015. Okay, so let's see. Okay, so who's coming up with another answer? Is it Spencer got or what I got? Evelyn, you got the 13.25015? Okay. Gabby, that's what you got? Okay. All right, good. Good, good. All right, so I think we just maybe typed the wrong key someplace. So for that one, I got 13.25015. All right. Now I need the sum for the other two rows. Okay, the square differences for the x's. Has anybody gotten that yet? Two point what? A little off. I got something a little bigger.
We're just adding up the totals of the second last row.
Yes. So now we're adding up from 8.2656 all the way through 0.01563. Okay, for this one, I got 22.87489. Is that what you guys are getting?
Oh yeah, my bad. I divided it by 8.
Oh, there you go. Okay. Okay. So 22.87489. Okay. And I'll just go ahead and tell you for the last one, I got 15.5. Is that what you guys are getting? Okay, good. I got 15.5. Okay. So let's go ahead on the bottom of your page. I'm going to have to go to another screen, but now we have all those totals here. So let's figure out what the covariance is. So remember the sum of that third to last row right there, the product of those differences. Remember we got 13.25015, 13.25015. And what's the number of terms we're talking about? 8. So we have 8 elements in each set. So we're going to divide that by 8. All right. And we'll go to the calculator in just a second. Let's go ahead and set this up. For the standard deviation of the x's, we have the square root of the sum of the differences for x, the 22.87489. 22.87489. Once again, divided by n. And the standard deviation according to the y, I believe that one was only 15.5 divided by n. Oops. I was just saying if you were paying attention. Obviously, Emily was right on target. There we go. All right, so let me go ahead and plug all these in my calculator. So give me 2 seconds here. All right, so first off, 13.25015. Okay, control divide. 13. What was it again? 25015. Okay, over 8. I'm going to go ahead and put period. Okay, so I'm getting my covariance to be about 1.66. Would you guys agree? Okay. Now for the next one, I want the square root of, we've got 22.87489 divided by 8. Okay. So I'm getting the standard deviation for the x's to be about 1.70. Okay. And last up, okay, control radical, put in another fraction here, and then I got 15.5 divided by 8. So I'm getting the standard deviation for the y's to be about 1.39. Okay. Now remember, all three of those are going to work together, so I'm going to go ahead and do this. Okay. You can use your touchpad or use your arrows. I'm not going to go ahead and approximate them now because I want the best answer I can possibly get. So I'm going to highlight it. I'm going to push enter. Now I want times this other one here. Remember, I have to take a product of the two. Okay. The two standard deviations. So 2.35372. So now I'm going to go ahead and go back up here. This one, I'm going to take that. No, we multiply. We took a product of the two standard deviations. So now I'm taking the value, the 1.65 that we got for the covariance, and I'm going to divide it by that product that I just got. Okay, so divided by, and I'm going to go ahead and highlight that again. So I'm getting about a 0.704, about a 0.70. Okay. So that would be my value of R, Pearson's correlation coefficient. Now, what would we say here? Is it weak? Is it moderate? Strong? Okay. It's the upper level. Now, remember, the way we broke it down, strong went from what to 1? 0.75. So we're at the upper level of about moderate. I mean, we're close. I mean, I would say it has a fairly decent relationship. It definitely could be stronger. Okay. All right. Now remember, that's how we're doing it by hand. So there's obviously sometimes going to be a lot to calculate, especially if you have these decimal values, which is why a lot of times we prefer the technology. So here's what I'm going to do. Let's go ahead and take that data set, X and Y. Let's plug it in again, and let's walk through the keystrokes. So how do I get to my spreadsheet? Okay, so I'll click 1. Okay. List and spreadsheets. All right, so I'm going to go ahead and type in my titles here, X and Y. Remember to arrow out or push enter after we do this. So let's see, my X's, I got 1, 5, 6, 6. Good, then we got 2, 3, 4, 4. Okay, and what was that little trick to get to the top? Control 7, okay. Now for the Y's here, 2, 4, 5, 3, 2, 4, 5, 3, and 1, 2, 5, 4. 1, 2, 5, 4. Okay. All right, so I have my data in. And think about all the values that we got. Ultimately, we ended up with roughly a 0.70 for our correlation coefficient. Where do I go now? What's that? Menu. Statistics. Stat calculations. Okay, now remember, we're not dealing with a frequency table. We are comparing two different quantities. So this is two variable statistics. All right, so the X and the Y lists are those headings that we just previously put in there. Okay, there is no frequency list, so I'm going to go ahead and delete that. And it looks like everything's going to appear in column D. So as soon as I push enter. All right, let me scroll on up to the top here. Now remember, I did say the mean was what? 3.875. What did we find for the standard deviation of the X's? Okay. 1.69. Okay, I would agree with that. Then we have the Y. There's the 3.25 mean. There's the standard deviation on the Y, the 1.39. And there is our correlation coefficient R. Okay. So even if you were to round like to 2 or 3 decimal places as you went through, would you still be close? Yeah, it's just not going to be perfect. It's not going to be as approximate. And then again, remember, this also provides you the information where you have all of the box and whisker information for X and also for Y as well. Okay. So you're given quite a bit of information when you go through those. All right, question. Is anybody having a hard time with correlation? No? Okay. All right. Well, the next page, let me go ahead and take this off right here. Okay, so we got that to be about 0.70, and there are the points right there. Okay. And one of the things we're going to go ahead and start to do later, and I'm probably going to show you this for the first time tomorrow, is how to go ahead and get an equation line. Probably on the calculator, and then the next lesson I'll work more with showing you how to do it by hand. Okay. So this is the calculator instructions. You can go ahead and take a look at that if you ever forget. Okay. And all right, there you go. We're going to pretend that that wasn't up there. Okay, there we go. So now let's go ahead and fill out this table together. Let's see if we can retrieve those values that I just got rid of very quickly. So let's see. So we'll probably go ahead and start this today. I've got 159. We may not go ahead and get through all the rows, but let's at least see how far we can get. Does somebody want to help me out with the average for X? So it looks like we got 8 terms again. So someone on your calculator, I need 2 plus 4 plus 5 plus 7 plus 9 plus 10 plus 11 plus 15. We need to take that sum and divide by 8. That's exactly what I got. Okay. Okay, so the X mean, 7.875. Perfect. And has anybody already calculated the mean for the Y's? I got 7, exactly. Okay, right on the money. All right, so here's what I'm going to go ahead and do. We're going to start with the X's first. Okay. I'm going to take the 2, 4, 5, and so forth. Each of them, I'm going to go ahead and subtract that mean. So first off, I need 2 minus 7.875. Negative 5.875. Okay. And we're going to go ahead and do one row at a time. So why don't we go ahead and now do the same thing, 3 minus 7. Oh, I'm sorry, I didn't square that. Went to the wrong one. Negative 4 right there. Okay. And now, let's go ahead and square that. So somebody square that mean in the calculator for me. The difference of those. So negative 5.875 squared. What do you get? Okay, so 34.5? Okay. Now, and here's the thing on that. I mean, when I did this, I went ahead and took it to 4 decimal places. But I'll go ahead and do what you guys want. And maybe if we only go ahead and take it to 1, we can actually talk about like how close we would get. You guys want to do that? You want to take it to 1 decimal place? Okay. So let's say 34.5. Everybody's okay where the negative 4 came from? Okay. So now negative 4 squared, 16. And now what I need is a product of the 2. Oh, what did I say? 34.5? Sorry. So 34.5 and 16. What's that going to give me? Okay. What's that? 152. Oh, yes, I'm sorry. Oops. Yep, we're multiplying these. Dadgummit, I did it again. We're supposed to be multiplying. No, I was right. Yeah. Good Lord. It's only Wednesday. What are you getting? 23.5? Is that what you guys are getting? Okay. Okay. I'll tell you what, why don't we go ahead and do like we did, I think it was like 2 or 3 weeks ago. We were doing this with another table. Why don't we get one at a time, people up here to go ahead and do one row at a time, and then we'll take a look at the table collectively. Who wants to go ahead and do another one before we take off? So many hands. Okay. Whoa, hey, I got you. Now, were you scratching your head or were you actually raising your hand? Hey, there we go. All right. So let's go ahead and do this one. Oh. Okay, so we're going to start off with 4 minus 7.875. Mm-hmm. Now we'll square that value. Yeah, and I got 15.02, so you just want to say 15.0? Okay. Okay. Oh, one thing we don't need there. The negative, there we go. Okay. And now we'll multiply the two differences, so negative 3.875 times negative 3. Okay, that's exactly what I got. Good. Okay. And it's only 2:03. I'll bet we can get away with one more before we go ahead and call it time today. Gabby, you want to do one? Okay. So Gabby's going to have the ordered pair 5 and 6. Okay, so 5 minus 7.875. Okay, negative 2. Good. Now 6 minus 7 after we square that. Okay, Okay, 8.3. Yep, I got 8.26, so I'd agree with that. Okay, -1. Okay. All right, it's looking good. That is a 2, yes. Okay. Good, good, good. All right. You know what? We might as well keep going. We're having fun, right? Hey, why not? We got 5 minutes. Who wants to go next? 7 and 6. Okay, Spencer? Cool. Okay. So him and I have run to the 0.875 to 0.88. Okay. That'll work. That's fine.
Just 1 decimal.
Yeah, 1 decimal, that's fine.
Yeah, it'd be negative. 7 like 7.
There we go. Okay. Okay. And we're right. I mean, the difference would be negative, but I don't think ultimately that's going to affect anything.
On this one.
On the Y's.
Oh, sorry, I looked at the wrong crowd.
That's fine. That's fine. I've made, my share of little mistakes too. Works out. Okay. Now that one would be positive, yes. Okay. All right, so I'll tell you what. I do have 206. Why don't we go ahead and call it there? So we'll have 4 more to go. I'm sure some people go home tonight and think about how much fun it would be to come up to the board. Graceland, I'm already looking at you. See, I can tell she wants to come up first thing tomorrow. Okay. All right, thank you guys very much. You did a great job. Yes, let me pass that out for you. Yes, yes, yes. Okay. So let me go ahead and stop this.